Now just now in demerit I had explained about the isotopes. So isotopes have same atomic mass, same chemical properties but different atomic mass. So this you have studied in your 8th standard. What are isotopes? Just recollect what you have studied. So atoms of the same element having different atomic mass, so the atomic mass number is different, is known as isotopes. For example, hydrogen, the atomic mass of there are 3 isotopes of hydrogen, that is 1H, 2H and 3H. What is the atomic mass of this hydrogen? It is 1, and second one is 2, and the third one is 3. So you can see all are having different atomic mass, but the chemical properties of all these 3 will be same. The first isotope of hydrogen is known as hydrogen, the second one is known as deuterium, and the third one is known as tritium. Similarly, isotopes of carbon is what? 12C, 13C, 14C. The atomic mass of the first isotope is 12, the second one is 13, and the third one is 14. Similarly, the isotopes of chlorine are what? 35Cl and 37Cl. So the atomic mass of the first isotopes is 35 and the second one is 37. So from this you can come to know they are isotopes of the same element but they are having different atomic mass. So there was a confusion where to place all this isotope, in the same box or in a different box. Why in different box? Because all the atomic mass were different. Now on page number 20 there is a question, write the molecular formula of oxides of elements. So looking at this you can write down the molecular formula. So Na comes over here, Na. So what will be this? Na2O. Si will come over here. So Si is what? RO2. So SiO2. Same way Ca will come over here. So CaO. Ca. Now what is C? C is over here, so it will come CO2. Rb is over here, so it will become Rb2O. So Rb2O. And P, phosphorus, is over here, so P2O5. Cl is over here. So what will be that? Cl2O7. And Sn comes under this group 1, so it will be what? SnO2. SnO2, not SN2O. SN2O. Similarly, elements with hydrogen. What is the molecular formula of elements with hydrogen? So see the blue colored one. C comes over here, so it will be what? CH4. Next S is there. S is over here, so it will be what? SH2. Where is Br? Br is over here, so BRH. So BRH. AS is over. AS is over here, so it will be what? ASH3. And F is over here. F is over here, FH. And O is what? O is OH2. This one, OH2. And N is what? N is over here, so NH3. Cl is over here, so Cl2, CLH. So hydrogen is this one, this is of oxygen. So this way you have to write the molecular formula according to the Mendelev's periodic table. Now modern periodic law. When Dobereiner, Newland and Mendeleev prepared the periodic table, it was based on what? Atomic mass. Later, why they had prepared on the basis of atomic mass? Because the interior of the atom was not yet discovered. When the interior of the atom was discovered, what was there inside the atom? There is a nucleus. Inside the nucleus there is proton and neutron, and the electrons revolve around the nucleus. So this was not discovered during the time of Mendeleev, Newland and Dobereiner. So they had prepared the modern periodic table on the basis of atomic mass. But when electrons were discovered, they related this number of electrons with atomic number. So what is atomic number? Atomic mass is different, atomic number is different. Atomic number is what? Number of electrons. Now in 1913, an English scientist what was the name of the scientist? Henry Moseley. He conducted an experiment with the help of what? X-ray tubes. He conducted an experiment with the help of X-ray tube, and he showed the protons which were there and this way he showed that the atomic number, which is denoted by what, which you have studied in your earlier standard, atomic number is denoted by capital letter Z. So atomic number corresponds to what? To the positive charge on the nucleus. Or you can also say it corresponds to, what is the positive charge in the nucleus? Protons. It corresponds to number of protons. Number of protons in the nucleus. तो डॉबरराइनर, न्यूलैंड और मेंडलीफ के टाइम में उन लोग ने जो पीरियोडिक टेबल बनाया था वो किसके बेसिस में बनाया था? एटॉमिक मास के बेसिस में। क्यों? क्योंकि उस ज़माने में एटम के अंदर क्या है वो डिस्कवर नहीं हुआ था। बाद में जब ये एटम के अंदर इलेक्ट्रॉन्स है पता चला, तो इलेक्ट्रॉन्स वर डिस्कवर्ड, तो इसके बेसिस में नंबर ऑफ इलेक्ट्रॉन्स, सो दे रिलेटेड द नंबर ऑफ इलेक्ट्रॉन्स विद एटॉमिक नंबर। तो नंबर ऑफ इलेक्ट्रॉन्स को किसके साथ, नंबर ऑफ इलेक्ट्रॉन्स को क्या बोला जाता है? एटॉमिक नंबर। सो इन 1913 इंग्लिश साइंटिस्ट हेनरी मॉसले, उसने एक एक्सपेरिमेंट कंडक्ट किया एक्सरे ट्यूब की मदद से, और उसने बताया कि एटॉमिक नंबर क्या होता है? द पॉजिटिव चार्ज ऑन द न्यूक्लियस। जो पॉजिटिव चार्ज है न्यूक्लियस के ऊपर, उसके ऊपर डिपेंड करता है एटॉमिक नंबर। नहीं तो पॉजिटिव चार्ज क्या होता है? प्रोटॉन। सो नंबर ऑफ प्रोटॉन्स इन द न्यूक्लियस। अर्लियर स्टैंडर्ड में पढ़ा था, न्यूक्लियस रहता है, उसके अंदर पॉजिटिव चार्ज प्रोटॉन्स रहता है और न्यूट्रॉन्स रहता है, और उसके आजू बाजू में इलेक्ट्रॉन्स रिवॉल्व करता है। तो एटॉमिक नंबर क्या है? पॉजिटिव चार्ज ऑन द न्यूक्लियस और नंबर ऑफ प्रोटॉन्स इन द न्यूक्लियस। Based on this, the modern periodic law was stated. What is modern periodic law? Modern periodic law states what? It is the properties of elements are the periodic function of their atomic number. And what does Mendeleev's periodic law states, which we have studied before? Mendeleev's periodic law states it is same like this law, only a slight difference is there. What is that? Properties of element are the periodic function of their atomic, not number, but atomic mass. Why? Because during that time interior of the electron was not discovered, so they didn't know about atomic number, they knew only about atomic mass. So that is the difference between modern periodic law and Mendeleev's periodic law. Now the classification. What is modern periodic table? The classification of elements resulting from an arrangement of the elements in an increasing order of their atomic numbers is a modern periodic table. Before, the scientist is to arrange the elements on the basis of what? Atomic mass. Now in modern periodic table it is arranged in the increasing order of the atomic number. The modern periodic table is also known as long form of the periodic table. Now in the modern periodic table, when the elements are arranged in increasing order, the order of atomic number, the properties of elements can be predicted accurately. Now whatever the drawbacks were there or demerits is also known as drawbacks of Mendeleev periodic table. We had studied this, I had explained about this. So whatever drawback was there in the Mendeleev's periodic table was removed, except one, which demerit was not able to be removed even in the modern periodic table, was the position of hydrogen. Regarding the ambiguity of the position of hydrogen was not removed. In modern periodic table. Now what is electronic configuration? Electronic configuration is what? That is arrangement of electrons around the nucleus in different shells depends upon what? Depends upon the total number of electrons. Depends upon the total number of electrons. And what is total number of electrons? The total number of electrons is nothing but atomic number. So atomic number is the number of electrons, and depending upon the number of electrons, the electronic configuration is done. What is electronic configuration? Arrangement of electrons around the nucleus in different shells. अभी पीरियोडिक टेबल, मॉडर्न पीरियोडिक टेबल क्या है? क्लासिफिकेशन ऑफ एलिमेंट रिजल्टिंग फ्रॉम एन अरेंजमेंट ऑफ एलिमेंट्स. तो एलिमेंट्स को अरेंज करता है कैसा? इंक्रीजिंग ऑर्डर ऑफ एटॉमिक नंबर. पहले साइंटिस्ट किसके बेसिस में अरेंज करता था? एटॉमिक मास के ऊपर. अभी एटॉमिक नंबर के ऊपर अरेंज करता है एलिमेंट. इसको बोलते हैं मॉडर्न पीरियोडिक टेबल. इसका दूसरा नाम क्या है? लॉन्ग फॉर्म ऑफ द पीरियोडिक टेबल. अभी जब भी एलिमेंट्स को एटॉमिक नंबर अरेंज किया इंक्रीजिंग ऑर्डर ऑफ एटॉमिक नंबर के बेसिस में, तो जो प्रॉपर्टीज़ ऑफ एलिमेंट्स है उसको अपन एक्यूरेटली प्रिडिक्ट कर सकते हैं. दूसरा क्या है? जो डीमेरिट, जो मैंने पहले एक्सप्लेन किया था, डीमेरिट ने तो ड्रॉबैक्स जो मेंडलीव पीरियोडिक टेबल में आता है वो सब निकल जाता है. सिर्फ एक, वो कौन सा है? पोजीशन ऑफ हाइड्रोजन. ये उसका जो कन्फ्यूजन है कहाँ पे हाइड्रोजन रखा जाए, वो मॉडर्न पीरियोडिक टेबल में भी नहीं निकाला जा सका, वो वैसे ही रह गया। तो इलेक्ट्रॉनिक कॉन्फ़िगर, अभी इलेक्ट्रॉनिक कॉन्फ़िगरेशन क्या है, दैट इज़ अरेंजमेंट। मतलब इलेक्ट्रॉनिक कॉन्फ़िगरेशन का मतलब क्या है, इलेक्ट्रॉन्स का अरेंजमेंट। न्यूक्लियस के electrons किधर होता है, revolve around the nucleus. So the arrangement of electrons around the nucleus in different shells, K shell, L shells, उसको different shells में कैसे arrange करता है, वो किसके ऊपर depend करता है, टोटल नंबर ऑफ इलेक्ट्रॉन। टोटल नंबर ऑफ इलेक्ट्रॉन्स को क्या बोलता है, एटॉमिक नंबर। मतलब एटॉमिक नंबर क्या है, टोटल नंबर ऑफ इलेक्ट्रॉन। अगर 8 इलेक्ट्रॉन है तो एटॉमिक नंबर उसका 8 रहेगा, अगर 7 इलेक्ट्रॉन है तो एटॉमिक नंबर उसका 7 रहेगा। Now this is a modern periodic table. In the modern periodic table there are 7 horizontal rows. How many horizontal rows are there? 7 horizontal rows are there. You can see over here 1 2 3 4 5 6 7. So 7 horizontal rows are there. These rows are known as what, periods. And how many vertical columns are there? These are known as vertical columns. So vertical columns are 1 2 3 4 5 till 18 it is there. So how many vertical columns are there? 18 vertical columns are there. And what are vertical columns known as? They are known as groups. So horizontal rows are known as periods and vertical columns are known as groups. In other than this 7 rows, there is 2 separate rows at the bottom of the modern periodic table, which is known as lanthanide series and actinide series. If you see over here, lanthanum, after lanthanum, that is 57, after 57, which atomic number comes over here? 58, 59, 60, 61 till lutetium, that is 71. That is lanthanide series are from cerium to lutetium, that is from atomic number 58 to atomic number 71, which comes after lanthanum. You can see over here 57 to 71, which is kept separately at the bottom. Actually it should come over here 57, 58, 59, 60 and so on, but it is kept separately. Similarly actinide series, it comes over here AC. AC is what? Actinium. After actinium, that is 89. After the atomic number, what is the atomic number of actinium? 89. After 89 it is placed over here 90, 91, 92 till 103, that is actinide series from thorium to lawrencium. So from thorium to lawrencium is placed in actinide series. Now why these two groups are placed below the periodic table, which should come actually over here after 57 and after 89, because their properties are completely different from other elements and they play a very big role in the shape, size and the history of the periodic table. That is why actinide and the lanthanide series are kept at the bottom of the periodic table, which should actually come over here, but they have been kept separately because they have different properties than the other elements. Now you can see on the top, atomic number is written, that is atomic number of hydrogen is 1, atomic number of helium is 2, atomic number of lithium is 3, beryllium is 4, boron is 5, carbon is 6 and so on. So you see in the modern periodic table the atomic number appears serially one after the other, that is after 1 we get the atomic number 2, then 3, then 4, then 5, 6, 7. So atomic numbers are appearing serially in the modern periodic table. Mendeleev had prepared and the other scientists had prepared the periodic table on the basis of atomic mass. Atomic mass is written at the bottom. What is the atomic mass of hydrogen? 1.1. Atomic mass of helium is 4, atomic mass of lithium is 6, atomic mass of beryllium is 9. So the rise in the atomic mass does not appear to be uniform. So they are not appearing to be uniform in the periodic table, but the atomic numbers are appearing uniformly in the periodic table. So next you will find that the modern periodic table is divided into 4 blocks. How many blocks? 4 blocks. What are they? F block, D block, S block, P block. So there are 4 blocks. What are they? S block, D block, P block and F block. What is S block? S block is group 1 and group 2. What is D block? D block is from group 3 till group 12 is D block. From group 13 to group 18 is what? P block. So from group 13 to group 18 is P block, and the lanthanide series and the actinide series are F block element. I repeat once more, group 1 and group 2 are S block element, from group 3 to group 12 is D block element, and from group 13 to group 18 is P block element, and the lanthanide series and the actinide series are known as F block element. Totally there are altogether there are 118 elements. Some of the elements were discovered experimentally, and recently they were discovered experimentally. So all the 118 elements are now discovered and filled in the modern periodic table. Now you can see the three types of traditional types of elements clearly in this periodic table. What are those three traditional types of elements? Metals, metalloids and non-metals. The elements which are placed on the zigzag border, the one which I have shown in red color is a zigzag border. So element which appears on this zigzag border which is shaded, those are all known as metalloids. So these are all metalloids, that is boron, silicon, arsenic are all metalloids. The elements which appear on the left side of the zigzag or the left side of the metalloids are known as what? Metals. And the elements which appears on the right side of the metalloids or the right side of the zigzag are known as what? Non-metals. So these are all metals, these are all metalloids, and these are non-metals. So on the right side of metalloid is non-metal, on the left side of the metalloid is metal. So all the three types, that is metal, metalloids and non-metal, can be clearly seen in the modern periodic table. Now use your brain power. In page number 21 it is given. The first question is, how is the problem regarding the position of cobalt, that is 59CO, and nickel 59Ni in Mendeleev's periodic table resolved in modern periodic table? So cobalt is what? 59 and nickel is what? 59. Now the Mendeleev's periodic table was based on what? Atomic mass. So there was a confusion how to place cobalt and nickel, because both were having same atomic mass. So whether to place cobalt before nickel or nickel before cobalt. So this problem was solved in the modern periodic table. Why? Because in the modern periodic table the elements are arranged according to their atomic number. So the atomic number of cobalt is how much? 27, and that of nickel is how much? 28. So 27 is smaller than 28. So which element will come before? Cobalt will come before nickel. So that problem was solved. So this number which is written on the top is what? Atomic mass. And the number which is written here on the bottom is atomic number. So you can usually come to know which is the atomic mass and which is the atomic number. So 59 is atomic mass and 27 is atomic number. Now second, how did the position of the isotopes 35Cl17 and 37Cl17 get fixed in the modern periodic table? So isotopes of chlorine are what? Cl 35 17 and Cl 37 17. Now if you look at the atomic mass is different. So in the Mendeleev's periodic table there was a confusion whether to place in different box or to place in the same box. Why different box? Because the atomic mass was different. And why in the same box? Because the properties of chlorine, isotopes of chlorine were same. So this problem was solved in the modern periodic table, because when you arrange the elements according to their atomic number, it is found that both the isotopes of chlorine are having same atomic number. Hence they are placed in same position, that is in the same box, because they are having same atomic number. Can there be an element with atomic mass 53 and 54 in between two elements? Chromium. So what is chromium? 52 Cr24. And between chromium and manganese, what is manganese? Manganese is 55 Mn25. So the question is, can there be any elements between chromium and manganese? Why the question is asked? Because atomic mass of chromium is 52 and atomic mass of manganese is 55. So they have asked the question, can there be elements with, after 52, which number will come? 53 and 54. So can there be two elements between chromium and manganese with the atomic mass 53 and 54? Can there be any elements between chromium and manganese? No. Why no? Because the atomic number, the modern periodic table is based on atomic number. The atomic number of chromium is 24 and atomic number of manganese is 25. After 24, the next serially coming number is what? 25. So there cannot be any elements between chromium and manganese. So there cannot be any elements between chromium and manganese. Why? Because the atomic number of chromium is 24 and that of manganese is 25 and is serially coming one after the other. So there cannot be any elements between them. What do you think? Should hydrogen be placed in the group of 17 of halogens or group 1 of alkali metals in the modern periodic table? Now we had studied the demerits and the demerits that hydrogen showed similarities with halogens that of group which is in group 17, and it showed similarity with alkali metals also, which is in group 1. Now it is placed in group 1. So this confusion is still not solved, but in the modern periodic table it is placed with group 1, that is alkali metal. Why? Because hydrogen gives away one electron, to form cation, to form stable cation, that is H plus. So it forms a stable cation by giving away one electron. Hence hydrogen is placed in group 1 along with the alkali metals.